video 2, and I have a feeling we'll have to go to 3 videos, but the third one shouldn't be all that long. And the next group of problems ask us to find the vertical asymptotes. Well, like I said, vertical asymptotes are generally the easiest, and in fact we've been finding pretty much the vertical asymptotes already. We just haven't been calling it that. And that is basically where is the denominator equal to 0. That's all we need to worry about here. For vertical asymptotes, that means where's the denominator equal 0. So number 7, I look at the denominator. X squared minus 36 equals 0. Add 36 to both sides. Take the square root of both sides so that x equals both a positive and a negative 6. So the vertical asymptotes would be x equals 6 and x equals negative 6. Remember, asymptotes are equations of lines, so you need to have this x equals 6 and x equals negative 6. You can't just have, as we calculated there on the screen. Number 8, x squared minus 25x equals 0. I can factor out an x, and so I get x times x minus 25. Set each one of these equal to 0. X equals 0, x minus 25 equals 0. Add 25 so that x equals 25. So x equals 0 and x equals 25. There's my vertical asymptotes. Example number 9. Number 9, the denominator is 49x squared plus 98x plus 45, and I'm going to set that equal to 0. And I can factor this out pretty quickly. 7x plus 5 times 7x plus 9 equals 0. So setting each one of these equal to 0 and solving. This one I'll subtract 5 and divide by 7 so that x equals negative 5/7. And subtract 9 and divide by 7. X equals negative 9/7. And there are the 2 vertical asymptotes that are asked for. So much for vertical asymptotes. Horizontal asymptotes are those that lay flat. And these are the next level of difficulty. Basically, horizontal asymptotes, they might be crossed in the intermediate, but they won't, in the ends, they will not be crossed. And that is true of vertical asymptotes as well. And so basically what I'm looking at is the ends, the negative infinity for x and the positive infinity for x. And so if I look at number 10, it appears like the negative side, it's getting closer and closer to the value of 0. It's getting closer and closer to that x-axis. Likewise, on the positive infinity side, it's getting closer and closer and closer to the x-axis. Well, the equation of the x-axis is y equals 0. And so we have y equals 0 is the horizontal asymptote. Now that's simply by looking at the graph. But how do we find that if we are given the equation? Well, this is where we actually need to simplify the numerator as much as possible. Maybe factor some things. Simplify the denominator as much as possible. Perhaps simplify some things. And then look at the exponents for both of them, because that determines what the horizontal asymptotes might be, or are actually. And so that's what we're going to be looking at. And so to find Horizontal asymptotes, well, let's look at number 11. Okay, number 11. I've got 3x squared plus 4 over 3x squared minus 4. And there's just not a whole lot of simplification that can be done. In fact, none of these really factors, so we can't really do anything with them. And so now we simply look, what's the degree of the numerator? The degree of the numerator, which I'm going to show with n, is not necessarily appropriate, but that's 2. And the degree of the denominator is also 2. So basically, since the degree of the numerator and the degree of the denominator are the same, then what we need to do is we need to take just these leading terms and set them one over the other. In other words, I'm looking at y equals, take just the first term here, 3x squared over 3x squared. And of course, this is very simple to simplify. This becomes 1. Or in other words, the horizontal asymptote is y equals 1. Now that's when the numerator and the denominator are equal to each other. Okay? The degree of the numerator and the degree of the denominator are equal. Then you just take those leading coefficients and simplify them as much as possible, and whatever that is, that's y equals, that is going to be your asymptote, your horizontal asymptote. Example number 12. Example number 12, we have x times x minus 1 over x cubed plus 49x. Well, I can factor out an x here in the denominator, so it becomes x over x minus 1, or x times x minus 1 over x times x squared plus 49. And notice those x's will simplify with one another, and so we get x minus 1 over x squared plus 49. Now this is about as simple as it's going to get, so I look. The degree of the numerator is 1. The degree of the denominator is 2. And so what I need to, since the numerator is less than the denominator, the numerator is less than the denominator, the degrees of those, then the vertical asymptote is y equals 0. Once again, if the degree of the numerator is equal to the degree of the denominator, you take the two terms, the two leading terms, simplify those as much as possible, and then it's y equals whatever they simplified to. If the numerator is less than, if the degree of the numerator is less than the degree of the denominator, then it's y equals 0, or in other words, the x-axis. Number 13, we have negative x squared plus 16 over x squared plus 5x plus 4. I don't like this negative out here, so I'm going to put negative, and then this becomes x squared minus 16. And this can be factored to x plus 4, x plus 1. So the x squared minus 16 can now be factored to x plus 4, x minus 4. all over x plus 4, x plus 1. So this x plus 4 will simplify with that x plus 4, leaving a negative x minus 4 over the quantity x plus 1. Okay, now it's as simple as it's going to get. So the degree of the numerator is 1. The degree of the denominator is 1. And since they are equal, it's very similar to number 11. So I'm going to take the leading coefficient, or the leading term, and simplify it. So it's y equals, okay, the leading term up here is negative x. The leading term here is x. And the x's cancel each other out, leaving negative 1. So y equals negative 1 would be the horizontal asymptote for number 13.